Now let us discuss the general characteristics of the compounds of alkaline earth metals. The compounds of alkaline earth metals predominantly are ionic in nature. But yes, of course, they are less ionic than the compounds of the alkali metals. The reason being they are smaller size, higher nuclear charge, and higher ionization enthalpy. Mainly the because of the smaller size, they have high polarizing power, due to which what we find is they are comparatively less ionic than the compounds of the alkali metals. Now let us first discuss what we find is their oxides and hydroxides. Now they all form oxide except strontium and barium, because they both of these forms peroxides. They are oxides specifically of beryllium and magnesium are covalent in nature because of very small size, and what we find is that they have the covalent nature in their bonds. One another thing, interesting thing is that beryllium oxide is amphoteric in nature. It shows both acidic as well as basic nature. Rest all of the oxides of these elements, the second group, they are basic in nature, and their basic nature increases down the group. What is most interesting, another thing is that all these oxides, this can be shown with the reaction, combines with water and they form their corresponding hydroxides. That's why we say that they are basic in nature. Now let us discuss their hydroxides. Now they all form hydroxides, of course. Their hydroxides are less basic than the hydroxides of alkali metals, but their thermal stability and their basic nature of these hydroxides of alkaline earth metals increases down the group. That is why what we find is barium hydroxide is also called one of the alkalis, as it is completely soluble in water and it makes the medium basic. Now, this barium hydroxide is very stable also, whereas what we find is the hydroxides of beryllium and magnesium and calcium, they decomposes on heating to their corresponding oxide and forms and releases water. Another good thing about beryllium hydroxide, which everybody needs to know, is that since its bond with the hydroxide is covalent in nature and it's an electron deficient species having only 4 electrons with beryllium, it easily combines with the OH minus ions and forms this complex, and this is how it satisfies this is how it completes its octet. Another interesting thing about this beryllium hydroxide is that we regard it to be very mild acidic in nature. The reason being not because it releases H plus ions. The reason is because it accepts OH minus ions. If it is taken in water, what happens is this beryllium hydroxide takes out OH ions from this water and forms this 2 minus, and it releases 2 H plus ions. So due to the release of these H plus ions, rather what we can say due to the acceptance of its tendency towards OH minus ions, this becomes weakly acidic in nature.